we need time to like build the actual questions.
Yeah. All right. Clicking going live. You are live. Oh, I need the actual YouTube link.
How to maximize PCBA design efficiency with reduced redesign.
What would happen if you swiped the water jet? You know what? I'm not clicking on that.
Do we have anyone in the stream?
We just went live, so probably not.
Probably not.
But I just got the link. Post it in our podcast discussion. And let's put it on Twitter. The Twitter sphere. I'll say that was the nice thing. Nice thing about Twitch is at least the URL was always the same.
True.
Tweet. Pin. Okay. Let's see, I got another topic. Oh, okay. Sorry about that, everyone that's watching live. You probably just watched Steve and I just type for like 5 minutes.
Exhilarating. Oh my gosh.
What?
Is this I'm gonna put a link
Uh-huh.
here, let me get rid of all this crap down at the bottom. I'm gonna put a link at the very end of our show notes. When I was at Macrofab, I swear we manufactured something with this enclosure. I was thinking it was um the ghost detector thing, but it wasn't. Or maybe it was a way early version of it.
No, the ghost detector was using a
It was a rectangle.
yeah, and that used a Takachi brand
Right.
enclosure.
But I swear I remember this exact box. in
I
something.
do remember that box, but it was not for the ghost detector. What was that?
Centex? No, it was not.
Syntax Paranormal was the ghost detector.
That, yeah, okay, yeah.
That was one of my favorite episodes of the podcast we ever did when we had Michael Lyons on.
That was way early on.
It was really early and it was super weird. It was such a weird
It
podcast.
was super weird.
My favorite thing about that was, oh, it's okay if we're used to it. The thing about that,
Only sort of kidding, right?
when we asked Michael Lyons, so do you believe in ghosts? And he's just like, dude, I'm just an engineer that designs these things.
That was
It's such a great response to that question.
Yeah, dude. He was a chill guy.
Oh yeah. I think the problem with that project, it was really just trying to figure out how to test them correctly.
Yeah, it was annoying because it was very subjective.
Yeah, it was very subjective, and my favorite thing was like, because the main thing about that product is it's an EMF detector, and like, you'd set them all up, and then start the test routine, right? And then it'd be nice and quiet, and then one would start to go off, and then they would all start to go off.
Yeah.
It was just like, well, are they bad, or is this how it's supposed to be? No idea.
Or you never know. Maybe they weren't designed like amazing for EMC compliance, and maybe one tripped all the others, and then they just started like blasting the environment.
Or Macrofab on Hutchins Street was haunted.
Or right, maybe.
I do remember I did pitch that idea, and the guy was just like, no.
I do remember also that a fluorescent light was part of the
Yes.
test, where you had to hold it up to.
Yeah, you had to hold up a fluorescent light to it and make it go off.
Oh my gosh.
That was a very interesting, because we had latent failures with that product. I don't know if you recall, but it
Out in the
was
field.
flux ingress into the sealed inductors.
Mm-hmm.
And that was one of our first products that actually had that kind of a latent problem like that from manufacturing. Manufacturing, not really incorrectly, but just because like the part itself didn't have anything about it, about like flux ingress being a problem.
Yeah.
But it was one of those, oh, we need to switch to a different kind of flux to prevent this issue from happening.
I remember that now. Yeah. Because it would corrode and eventually break the inductor.
Yes. And so that the tank circuit would just stop working. That was the EMF detector part of it.
Right.
Yeah, that was like our fourth product, I think, we built at Macrofab.
That was a fun one.
Solder flux, Metacon. So what would happen is, because we were using a water-based flux for that product, and actually I think everything at that point was water-based.
It was.
Flux would go up the leads, and basically calipari action would just suck up into the inductor, and you couldn't wash it out, and water-based flux is corrosive, and so after a while, I think it was like 6...
It would eat to the enamel.
Yeah, it would eat through the enamel and then start eating through the copper inside those inductors. And so that was solved by going to... First of all, we had to replace all the inductors once we figured that out. And then we just used no clean.
And those were through-hole inductors, if I remember right.
Yeah. So actually it was pretty easy because it was just like we just used one big chisel tip to heat the inductor, pull it off, and then put a new one in, and we used
Yeah.
no clean instead, which didn't have the problem with it being corrosive. The real solution would have been to use like an SMT cap, but that was not in the bill of materials.
I wonder if ghosts emit positive radiation or negative radiation. In other words, if you have the inductor installed backwards, are you detecting a ghost in front of you or a ghost behind you?
Oh, like they're polarized?
Yeah, yeah, yeah.
They have a
yeah.
certain spin to them.
Spiritual spins.
Spiritual spin. That would have been a perfect name for this podcast if we were recording the podcast right now.
Yeah.
That was a fun project. I actually really miss building that product.
It was goofy. All those damn blue LEDs.
Oh yeah, the blue and red. It had blue, yellow, and red LEDs on it for like part of the EMF detector meter. It was super cool.
And you could flip the little speaker on, and you'd be walking by manufacturing. All you hear is.
Yeah, yeah. For like basically 4 months, because that's all we built for 4 months was that was that product.
Yeah.
Ah, that was so much fun.
I'm not clipping, am I?
No,
Okay.
sound good. I don't think I'm clipping though. I'm not even. I'm barely touching halfway up the yellow on my end. How's it going, Meta? Or Colin, I should say, since I know you in real life. How was Tuesday at the Fab? I've been getting everyone on the test engineering team up to speed of all like the that one product I've been working on, the tester for it.
Mm-hmm.
You know, for like the past 3 years or whatever.
Yeah.
Like I'm transitioning back into applications engineer role and stuff. So I'm like decoupling myself from the test engineering team that I helped build. And part of that is like handing over 3 years worth of knowledge to people.
It's a lot, right?
Yeah, it's a lot. And basically I spent like half of today like getting people up to speed on software, the software side of it. It's really weird to do like walking people through code. So,
Mm-hmm.
been stressing about getting CFM IFC out. Oh, yeah. Yep. What's CFM? I know what IFC is.
Cubic feet per minute.
Cubic feet per minute of Python code. Yeah, well, no, it's not really tribal knowledge code. It's all documented, but they wanted me to like actually walk through the code with them so that they can start supporting the code themselves.
That makes sense.
Because right now it's like if I'm not like if I'm not working on on test engineering stuff, I'm working on other stuff. Then if something bad happens, they have to go, okay, Parker, we need you to go fix this. And I'm like, well, operations has currently booked me for like 2 weeks of projects, so I can't go help you fix that.
Right.
So they're hoping to take more of it over so that stuff
They need to
doesn't happen.
own all of it.
Yeah, and it's understandable. They need to own that stuff. And we got some pretty smart people in test engineering that can do development work now.
Cool.
Maybe not quite up to like Metacolin's speed of development, but they're pretty good. Oh, customer furnished materials. That's what that project is called. Oh, good old consignment parts. Let's start this podcast.
Let's do it.
Oh, we need a new section here.
Organizers.
You want to? I've been doing the last couple. You should.
Yeah, I'll do it. You ready?
Yeah, I'm good.
Welcome to the Macrofab Engineering Podcast, a weekly show about all things engineering, DIY projects, manufacturing, industry news, and multimeter showdowns. We're your host, Stephen Craig.
And Parker Dolman.
This is episode 372.
Okay, so we got some news. You've probably been listening to this news a lot, though, but May the 4th is coming up. We have a event here at Macrofab HQ, which is in Houston, Texas. It's going to be May 4th, 2023, 6 p.m. to 9 p.m. Central Time at 10305 Roundup Lane, Suite 400 here in Houston, Texas. That's our HQ where we have our factory. And I'm actually going to, it's like a behind-the-scenes tour of our new facility. There's going to be food and drink and other things that they've been telling me about in marketing. Like, I still got to confirm some of it because some of it sounds pretty wild, but we'll see what's going on. But I'm going to just read the events page, which you can get to by going to macrad.com/events/may-the-fab-b-with-u. I probably should get marketing to get like a shortener. I wonder if you just go to macrad.com/events. Yes, so if you just go to /events, this event is there that you can click on. Okay, good.
That's a lot easier.
That's a lot easier. But if you go to that event page, there's registration, so you have to register and all that good stuff. So you can make sure that we have all we have enough stuff for everyone.
So goodies and food.
Yes. So I'm just going to read this page because I was reading this earlier and I'm like, this is like my favorite thing ever. I'm so surprised that marketing wrote this because this is something I would write for how silly it is. It's perfect. I love it.
You're finally, after what, 9 years, you're rubbing off on them.
Yeah. But join us for an exclusive event where we'll explore the latest advancements in our industry and unite in the quest for technical innovation. See details below, and may the force of innovation be with you. So it says May 4th, 2023, 6 o'clock p.m. to 9 o'clock p.m. Central Time, Macrofab 10305 Roundup Lane, Suite 400, Houston, Texas. And then it continues. Join the rebellion against mediocre electronics manufacturing and unite with Macrofab at our May the Fab Be With You gathering on May 4th in Houston. It's the largest congregation of EMS professionals in the galaxy, and we're inviting you to be part of it. May the force of good electronics be with you. Make the Kessel run to Houston so you can experience the excitement up close, attend our May the Fab Be With You event, and catch all the action. And here's a list of all the action. Take an exclusive tour of our newly expanded production facility and see firsthand how we're building the technology of the future. Have a chance to meet and talk with our team of Rebel electronic experts. Connect with other like-minded colleagues across the universe, all while enjoying tasty refreshments fit for a Jedi Knight. The Force is strong with those who join us on this quest to revolutionize the galaxy of electronics manufacturing. Register now and prepare to embark on a journey that will long remembered in the annals of history. Together we will unlock new possibilities and forge a path to a better tomorrow. And then there's the registration.
I love how much they leaned into this. Like,
oh yeah, I love it.
They went full ham on it.
Yeah.
It's great.
And I like how I was talking about that and we lost like 2 viewers on our stream. I think they're giving away lightsabers. That are like, they say like Macrofab or May the Fab Be With You or something like that on them. And there's been talk of like, it's not in here, so I don't want to promise anything, but I think there's going to be a costume contest. I think. I have to check. It's not in here, but they were talking about it. I'm probably going to dress up. So
Well, I guess there's it's about 5 weeks off.
Yeah.
So there's still a little bit of time for things to gel and solidify.
and there was talk about doing a podcast live, and I don't know if we're doing that yet, Steven. I have to find out. So if that's true, I'm like, well, we got to get Steven to Houston.
Well, okay. The funny thing about that is that may actually work out with what's happening next for me. Who knows? It may be possible that I might be in Houston around that time anyway. So perhaps we could make that work out. I mean, I could always come down regardless, because that sounds like fun.
No. So yeah, it's macfed.com/events. Go click there and register for the event. Should be a lot of fun.
That would be awesome.
Okay, so on to the actual topics at hand. So the first thing is, I think this is actually no. You actually removed that link from earlier. A couple weeks ago, I found a enclosure from Bud Industries. I don't remember what I was looking for. I think I was trying to find a part number of another enclosure I've used before, and then I found this, and it's called the Boardganizer.
Board-ganizer.
Yes, enclosure kit. There's gonna be a link in our, because that's probably really hard to Google for.
But yeah, because ganizer is not a normal word.
No, it's not a normal word. But it's a. You said it earlier. It's a CubeSat type device. So it's about 4 inches. It looks about 4 inches by 4 inches by 4 inches cube.
I think you're close. It's 5 by 5.
Okay,
is what it says on the website.
And it unfolds into to be laid out flat, and then you can put breadboards and your evaluation boards on the inside and kind of wire them up how you need to wire them up, and then you can kind of fold it all together into its protective CubeSat cubeness.
It really does. Gosh, when I first started at Macrofab, there were two engineering students who were working there, and both of them were on a team at University of Houston making CubeSats, and they had a little enclosure that was I don't know, it was clear acrylic. It was red acrylic.
I printed that.
You printed that?
I printed that on my printer. It was red.
So my memory's a little foggy, I guess, but
yeah, it was 8 years ago.
When I saw the Boardganizer, that's the first thing that came to mind, because it looks exactly like that. So for those who don't know, a CubeSat is a small cube satellite that they're projects that I've seen at many colleges around where you build a small satellite and they basically take it to space and they just open the doors and push them out into space, literally. It's just, here you go. And I guess that you could design telemetry or some other kind of, I don't know, sensors or something. It's an engineering challenge that I guess eventually a lot of them actually do get released into space. But yeah, this Boardganizer from Bud Industries looks spot on, exactly like that.
Yeah. I bet you it was inspired by CubeSats for sure.
For sure, yeah. The thing that I think is funny about this is basically what it is there's 4 plastic plates that have hinges on them, and you lay them out flat on your bench. You build them onto this thing, and like Parker said, it kind of twists, rolls up, and you can then just affix it into a cube. But there's not specific connection points. It's just 4 plastic plates that you double side tape your stuff to.
Yeah.
So it's kind of in the grand scheme of prototyping, I guess if you think of the bottom of the barrel, you have just a raw breadboard, right?
Yeah.
And I'm not saying bottom of the barrel isn't bad.
But it's actually a breadboard that you cut bread on.
Yeah, right. So this is one step above breadboard in protection level of your product.
Yeah. I mean, sure, you still got wires around and stuff, but at least it's contained. And honestly, when I was in college, that would have been awesome to have.
I agree.
To be able to roll up your lab into this protective cubeness of plastic, instead of being having to hold your breadboard and like duck and weave through like hallway traffic. So like you need
Or hold your breadboard and ride your bicycle.
Oh
to
yeah, I've done that
college.
before.
I have too.
Yeah. You hold it like a pizza in one hand and trying to ride your bike with the other hand.
I've got a delivery.
Yeah. And if you crash,
Yeah.
you fail.
I could also I could see this being something like really useful for having you build up your whatever you're looking to test. You kind of snap it all together and you push it away, and it's at least self-contained and it's enclosed enough, but you could still access all of your whatever you're
all the
messing
widgets
with.
in there.
So, yeah, it's cool. I would totally use one of these things for like a quick and dirty. I need an enclosure, but I don't want to go to the drill press. Give me some double side tape, and I'll just
stick it all together.
everything together. Yeah, I like it.
I think this would be great for students. Like if I ran a embedded systems class, I would be like, this is part of the thing you need to get, and you build your circuit on breadboard and stuff inside of this thing. Just because, like, just like the heartache of dropping your breadboard pains me so.
I love seeing this kind of stuff because, in some ways, it doesn't look serious, and I'm not saying that as in like a bad way. It doesn't look like this high end enclosure product.
No, it's not.
But it has full on engineering drawings, and it's got a goofy name like Boardganizer. That's something we would come up with.
Yeah.
You know? Like, I love that. It's so great. And on top of that, it's not pricey. I think we saw it for what, like $18 or something like that?
Yeah, and that's in singles at like Mauser. I think it goes down to like 8 or something like that. Let me check real quick.
What, if you're going to be manufacturing hundreds of these or something?
Well, I imagine if like you were running an embedded systems class, you would buy them in bulk.
Yeah, actually, that would, or like a lab for some college class. I could see that being really useful.
Yeah, it looks like $12.30 is about the cheapest they get. And I bet you if you like called out Bud and been like, "Hey, Bud, I got some embedded system students."
Do you think people do that to them?
Oh yeah, 100%.
When you call into their applications line, you just, "Hey, Bud."
Hey, Bud. Oh,
okay.
100% that's what's happening.
I have one suggestion if anyone from Bud is listening. If there is a way to make like a little snap-in handle so this could be like a little briefcase
So
that
like
you
a
could
GameCube?
carry in. Yeah, but then like the handle disconnects and it unfolds and your lab is there, right?
And then maybe
That
like a
would be
lunchbox.
neat. Yeah, exactly. The lunchbox organizer.
So that is the Boardganizer. You know, it would be cool to get like someone from the enclosure industry on here. Bonus
Bud?
points would be Butt Industry, so we can talk about the Boardganizer.
I'm looking at the drawing that they have for it, and it doesn't. In the title block, I'm not seeing
A name.
a name or initials. You know, so
Maybe that
perhaps
person's
on the customer facing front they don't show. that
Yeah.
stuff.
Okay.
It's made from ABS with little, I guess, steel hinge pins on it. Which, hey, if you drop it, it's not going to just shatter, right?
Yeah, exactly.
I mean, your breadboard's going to all
fall apart and all the wires get jumbled up.
Yeah.
It's a cool idea.
All right. Yeah, I like it. So, let's move on. So, ever since I was a young fledgling engineer in college, I always lusted after having good equipment in my home shop, and multiple times throughout this podcast, Park and I have talked about good enough equipment, but today marks kind of a special day for me because it's like I'm a real engineer now. I was able to acquire a Fluke 87V multimeter, and it feels special because I feel like I finally made it now. I'm an older engineer, you
Older
know.
engineer.
Yeah, I finally have like a respectable multimeter. But I wanted to talk about that because Parker and I have talked multiple times about multimeters and having just good enough equipment, and I still feel like that is acceptable and reasonable. The meters that we've used in the past, we've talked multiple times about our Harbor Freight Wonders that we bought, and I've gotten this far in all of my projects and even stuff at work using a Harbor Freight meter. But now I just had that deal that I could not pass up on a big boy multimeter. But earlier today, I pulled up data sheets of both my new fancy 87V Fluke versus my Centex 61593, which is just a Harbor Freight Wonder, and compared the two. And the first thing I noticed, the Centec, if you go right now to Harbor Freight, you're going to spend $39.99 on this multimeter. And if you go to Fluke right now and look at how much they're asking for an 87, it's $520. So we have an over 10x cost difference between these two. So I'm wondering, is there a 10x difference or a 10x difference between these two? So I wanted to do a quick comparison, but beforehand, Parker, I know you have a different meter that you've been using. What is your daily driver?
So my daily driver meter, I have a in quote Velleman, which is like a brand for like hobbyists, but this is just like they just slapped their brand on this. The model's like DVM 850BL. If you like start looking, like if you Google that, you will see a meter, and then just go on Amazon and look for multimeters, and you'll see a lot of meters like this one that have like 850L or something like that in its model number. It's something I bought at, I think, Radio Shack for $25 when I was in college, and I've dropped it at the beach, in the sand, in salt water. It's lived on top of it running engines. I can't kill it. Like one time I did, like it got really crunchy, and I opened up and I took sand out of it and put it back together, and it still functions just fine. And I have hooked it up to like a really nice Fluke meter, and it got the same numbers. And I'm like, for what I do, digital circuitry stuff, it's fine. Now, of course, we were talking about couple months ago, the cat feeder on reminder, which is really low current draw. There's no way this meter can help me out there. So
Yep.
I had to up my meter game on that. But for majority of stuff, like I still use that Velleman. That's the meter I grab all the time.
The beater meter.
Yeah, exactly what it is.
Well, and I can tell you this, even though I'm excited about my new yellow toy here, I'm still going to use this Centec. And I will probably, if I need to go stick some probes in a wall socket somewhere to see if it's live, I'll probably grab the Centec, or just whatever's closest to me.
So what you're saying is the Fluke meter, though, is like your Instagram, like, influencer mod. Like, when you go and, like, want to like show off, like someone's watching, that's when you're going to take the Fluke out.
Yeah,
and you'll have a leather case for it.
It depends on who. Yeah, it's who I'm talking to and who's looking at me, right? Yeah, if I'm in an interview, I'm talking Flukes, right?
There you go.
But if I'm just banging some stuff out on my bench, it's either or.
Either or, whichever one's the closest.
Yeah, whichever's, yeah. Actually, okay, and before we get into the difference of these, I picked up this meter today. What's the very first thing I do after I get it? I go to Amazon, and I got some sharp probes. I got a brand new set of sharp probes, and it was $9 shipped.
Yeah, those $9, they're $1 more than the last time we talked about them.
Yeah.
Inflation's killing us.
And I have a pair of those, but they're slightly bent because someone cranked on them when trying to measure something, and so it's like I just need a fresh pair.
Someone,
But
huh?
if I got this new toy, no, it was not me. I actually promise you that. I do try to take care of my meter probes and my scope probes as much as I can. You know, I actually had an engineer at a previous job tell me to solder a scope probe to a board once, like just straight up. Take the tip, stick it on the board, and solder it in place. He's like, if you need the best connection, you have to sacrifice the probe. I was like, I don't think I'm gonna do that. And I was able to get the information I wanted, but
That guy has like an annual $10,000 budget for scope probes.
yeah, single use scope probes.
Yeah.
Now I don't remember what I was measuring. It was some kind of, I don't know. It was some kind of high speed signal, but I was able to get what I needed without having to do that. Okay, yeah. So let's take a look at the difference of this. Remember the comparison I'm doing here is $520 versus $40. Do you get that much value, shall we say, between them? So first of all, the fluke I have is actually an auto range fluke. You don't get a choice. Well, you can, but if you just turn it on, it's gonna auto range. Fluke is kind of the best at auto range because it's just quick. It's really fast. It gets you there. It's snappy. It's never been an issue for me.
Yeah. I would say with flukes, the auto ranging works really well. It's never been a problem.
And I was actually playing with the auto range earlier today, and it has a boatload of hysteresis on it, actually. So if you go past the auto range point where it trips and goes into the next range, and then you come back, you have to go way back before that threshold point for it to switch, which is actually really convenient.
Yeah, so it's not just
so that it's not bouncing in between a lot.
Yeah.
They tried to make it as seamless as possible, so you're not just annoyed with it. Because I have worked with auto rangers that are like comparator edge.
Yeah, and it just keeps flipping around right on that like 6 volt. You have a signal at like 6 point something volts, and that's like where that auto range flips.
Yeah.
Oh man,
and it just goes freaking nuts. Yeah, because I think this fluke was switching. It was switching around 6 volts, and it was 6 point something. I don't know, 6.4 or 3 something that it was switching. But I had to go back down to like 5.6 for it to go back down the range. So that is also interesting though, because you have different. It displays different resolutions depending on which way you approach your voltage. If you're coming high, low versus low, high. So that's at least something to consider with that. But regardless, auto ranging on this is not an issue. Now my Centec has it's just selectable ranges. You just turn the dial, you get there, and there is a slight benefit, I think, for you selecting the range you want. And one of the reasons why I say that is because before you measure the voltage, you have to have some level of confidence about what you're going to measure because you're setting it up for that. And I think that's actually kind of helpful. In other words, like, you don't just stick your meter on there and if it says overload, spin the dial until it doesn't say overload. That's not a particularly helpful way of doing it. Like, if I take, for instance, the circuits I deal with, I'm talking about 500 volts. Like, if I'm going to go probe 500 volts, I know in my head before I even pick up my meter, I'm going to be looking at 500 volts, and I set my meter for that. It's not like I just stumble upon 500 volts. And so with the fluke, like, it being an auto ranger, you can just tap on it and it'll just jump to 500, be like, oh, that's 500. I just think that there's a little benefit of you knowing what you're trying to measure before you go and measure it.
It probably helps complacency. In your case, 500 volts is what you would call like the not fun to touch zone of voltages. Yeah. And so being complacent about that, I could see how that could help complacency and make it a little bit more safer, where you're like, oh, I'm actually going to be measuring 500 volts, so I should be more careful.
Exactly. And just the fact that you say, I need to measure a voltage, and the fact that the Centec makes you select the range, kind of prepares your mind for the impending doom that you're about to measure, right? It's just I don't know, it's a safety thing in my mind that I think I'm going to give a slight edge to manual range on that.
Oh,
So
we're actually going. You actually like picking and choosing winners here.
picking and choosing winners. So we'll see what we end up with here. The excuse me. So in going through the data sheets for these to find the more nitty gritty details like resolution and accuracy, that kind of stuff. First of all, the Centec is a 2,000 count, so 3.5 digit, and the Fluke is a 6,000 count. So you're going to be able to display a lot more before it shifts range on the Fluke, quite a bit more. The Fluke by default is also a 3.5 digit. So they're both comparable in that sense. However, the Fluke has a mode that you can hold down a button and it goes into high resolution mode and it switches from a 6,000 count to a 20,000 count and turns itself into a 4.5 digit meter. So
is there a reason why that's not on all the time?
I think battery usage, because it consumes a bit more juice when you do that. I believe so. I don't fully have that backed up, but I don't know the answer to it. But if you need that extra digit of accuracy, you can go into high res mode on the Fluke, which is pretty cool. So the Fluke obviously wins in this category: 6,000 count, 20,000 count, up to 4.5 digit resolution in your hand. Now, on almost every single category, I'm even going to say every single category, the Fluke is more accurate, and most of the time it's 4x or better accuracy than the Centec. Also, on top of that, the Centec has a lot of conditions with its accuracy. It'll say it's 1% accurate across this range, and across this range it'll be 2% accurate or whatnot. There's a lot of derating on the Centec, whereas with the Fluke, it just says basically across the whole range, for this measurement, it is this accurate kind of thing. And like I said, in almost every category, it was 4x or better accuracy. So the Fluke just blows the Centec out of the water. And I think that's kind of the main difference. That's the bulk of that 10x cost difference between the two, is just you're going to have way more confidence in the Fluke telling you the right answer than the Centec. Even though the Centec could give you the exact same result, you can have way more confidence with the Fluke. On top of that, the Fluke, they very likely have a much, much more advanced calibration than the Centec. I don't know anything about how the Centec is done. The Fluke, you can actually order calibration certificates with them when you get them. There's just a many steps up of professionalism and calibration with the Flukes. So the Fluke absolutely blows it out of the water on it. Another thing about this Fluke is it actually has backlit screens with different brightness levels, which is really nice. The screen looks good at lots of viewing angles. The one thing that the Centec has that I think is funny is the screen has a little, you could probably hear that. The screen can kickstand.
See,
out.
I actually wish my meter had that.
Well, okay, so instead of the kickstand on the back of a Fluke to have it stand up, the screen on the Centec tips up at an angle. So you can keep the meter flat on your bench and tip the screen. And I've actually found that to be a really convenient option.
Yeah, I'd love to have that. And I'm kind of deviating a little bit, but a flip-up screen, and you know how some of them have the strap on the back that has a magnetic disc? I wish I had a meter that had one of those too.
Yeah. I believe Fluke actually has a meter. I don't remember the number, but it actually has a wireless screen that you can disconnect.
Oh, I've seen that. Yeah.
And you can put it anywhere you need, which is kind of awesome actually.
That is cool.
That way you can have the screen where it's most visible for you. but that's also super wanky. And the amount of times I've ever needed something like I guess in automotive that would be
Yeah, I'm about
probably
to say,
pretty
I'm like,
awesome.
I could use that probably like once a month, because otherwise,
Yeah.
I'm like, if I'm measuring voltage and stuff like that, like I'm running like alligator clips super long to like hook stuff up,
Daisy chain.
daisy chaining stuff together, just so I can get the screen somewhere where I can read it when I'm like
Right.
manipulating something or whatever. Um, that's about it though, for me. I could see you setting that up where like the multimeter could be in like the danger zone when something's activated, and you can
Hmm.
have the screen with you to see what the measurement that you're taking is. Um, that would be really useful for that kind of feature.
Or maybe I don't know, you're in an electronic cabinet or a large one and there's a convenient spot to measure voltage, but not at the same spot a convenient place to measure current. You could have two meters and have both of the screens near you, but one of them physically in a different
Yeah,
location.
yeah, yeah, yeah. That'd be. I'm thinking that's like that would be a really cool feature to have.
It's super cool, right? But it's also very expensive.
Yeah.
So, but yeah. So honestly, between these two, I've used the flukes
Oh,
a
no, you got
lot
one more
in.
comparison in here you missed.
No, I do. I'll come back to that. I'm just
Okay.
on the kickstand thing.
Oh,
I
okay.
actually prefer the Centec flip screen as opposed to flukes. I've been using flukes since college, and the whole flip out kickstand thing is cool, but the flip screen on the Centec I think it beats it, to be honest.
Hmm.
And I'm gonna do real quick. This is not. You can see it on the stream. I'm gonna do the Dave Jones test. If you've ever watched EEV blog, when he gets a multimeter, one of the very first thing he does is he grabs it in both hands and he tries to torque it. And that's like his test of like durability, and I kind of love that. And that's his test of like, does it feel skookum?
Huh.
So of course the fluke is feels beefy. The Centec just as beefy.
Okay.
I can't really tell the difference. So not a very scientific test. But I suppose if you did have a really crappy meter, it might flex or whatever. Okay, and then the most. Oh yeah, but Parker's flexing his. Nah, he shrugging
Feels
his shoulders.
okay.
Yeah, feels
You can
fine.
hear
I thought
sand
I thought I
inside of
might.
it.
It's still crunchy.
Still a little
Hey,
crunchy.
I thought I might give a nod to Dave Jones and attempt his test. Okay, so one last thing, and this is the most important thing that a multimeter can do. Parker and I have talked about this many times. Is the all important beep test,
Continuity
because
tests.
that continuity test on a meter is like the number one thing I use for meters for, and I will give it to the fluke. The fluke is damn near instantaneous.
That's nice.
Uh,
Yeah.
it is so fast, and my Centec is quick. For a lower grade meter, I gotta give it credit, but the fluke is nearly instantaneous, and so it's just chef's kiss.
How loud is it?
Uh,
That's
Let me
that's
get
like for
some.
me. That's the most important thing. Is usually I'm in the garage working on stuff and I have music on, and if I have to turn my music down to hear my meter, there's something wrong.
Yeah, you need like 10 watts of.
Yeah, exactly. Needs an amplifier in there.
Are you able to hear that?
No.
Is that coming through?
Okay.
It's I would say loud enough for office work, but automotive, this is probably not going to do it for you.
Hmm.
So it's quick. It is funny because I work, the office next to me is where they do RMAs and repair stuff, and that's all I hear all day long is beep beep beep. So all said and done, it's not going to be that much of a surprise, but the fluke certainly beats out the Centec. But as Parker and I have said many times on the podcast, do you need a high quality like this grade of meter for most of your stuff? No, absolutely not. I think it's one of those things where if you do need it, you know you need it kind of situation. And I just got a screaming deal on it, so I was like, I gotta have it, just to have it. And mainly, I gotta have it so now I have 2 meters. Like, it never hurts to have more than one.
What if you bought a Centec for $39.99, and then you bought a can of yellow spray paint for $4.99?
Yeah, the Fluke Tech. I think you're onto something there, Parker.
Or the Saint Luke.
Well, it's a so in this deal I actually also picked up an oscilloscope, which is fun because I've been using an analog scope for years and years, and digital scopes are just so nice.
They are
what they offer. So I got a screaming deal on that too. So I couldn't turn it up. So I ended up getting a Rigel DS2072, which is it's not like super amazing or anything like that.
Yeah, but it's a pretty good meter. All right, a good scope.
It's a great scope, but I mean, you're not going to be doing like crazy high speed stuff on it. But then again, I don't do crazy high speed stuff.
Yeah.
So for a daily driver, it is a really great scope. So I'm really excited to start playing with that.
I'm glad you got some really good deals on some good equipment.
Hey, it only took me, what is this, 13 years or so, and I'm finally an engineer now. I have a Fluke.
Finally an engineer now. All right, so the next topic is, this is kind of like a broad topic, but it's only because something recent came up in my life that kind of like jogged my brain on maybe some techniques that engineers could use. And the topic's going to be debugging things that don't work, which is like, if you could write one sentence about what engineers do, that's it, right?
Yeah, engineers debug their own things that don't work.
Yes, but
like they make the thing not work.
Yeah,
and
they
then
make
debug it.
Yeah, they make the thing not work. So what brought this up is my Jeep Wagoneer, ever since about last fall, hasn't really been too happy with its life. Okay, it's been like backfiring and not running correctly, and more recently it's been even worse, like to the point where like you can't really drive it that well. I drove it down to Galveston this past weekend, and basically I picked up some crawfish, and so we had a big old crawfish boil down in Galveston, and I was kind of like worried that like hopefully I don't have to pull over the side of the road and like the crawfish boil in the back of my Wagoneer, right? And
gross.
And then I actually managed to hobble it back to Houston. And so on Sunday I was looking into it, and I'm like, okay, what's up with the engine? Make sure it has fuel pressure, all that good stuff. I started running some basic diagnostics on it, and threw in some like snake oil into it to see if it it was like a sticky valve or something like that. And nothing really was solving the problem. And I'm like, okay, let's get down to basics. Let's do a compression test on all the cylinders and figure out because like at this point I'm like, there's something mechanically wrong with this engine, and I'm like, it's got 220,000 miles on it. It was not taken care of well before I got it. So I'm like, okay, it might be on it. It's on its way out. And so on the second cylinder I do a compression test on, the spark plug wire just disintegrates in my hand. And these are, by the way, these spark plug wires are only about 8 months old.
Oh.
Yeah.
Okay.
And I'm like, I bet you that's the problem. And I pulled that one plug out, and that plug is pretty fouled up. It's got oil and stuff on it, so it wasn't probably firing much at all. So I cleaned the plug, put it back in, replaced the wire. Lo and behold, it runs like a brand new truck now. I still don't know if it's completely solved the backfiring issue because I haven't brought it onto the freeway at speed yet. But it's kind of interesting. this whole journey of finding a bad spark plug wire and what's happened since then. Because last summer it was the Wagoneer ran on a carburetor. It was still a carburetor fueled engine, and in the fall I decided to switch it over to electronic fuel injection. There's a kit set you can buy that basically you bolt on something that looks like a carburetor, but it's got fuel injectors instead of gravity fed or Venturi fed jets for the fuel. And so to do that part, though, I had to put a new intake on the engine. So I bought an intake, put it on, put this carburetor or this fuel injection module thingy on, and it ran great, but it backfired every so often. Like you'd be driving down the road, and then it would backfire once on the freeway, and then whatever. And I always thought it was like a fuel issue, right? Because like I just put this new fuel injection thing on. It's got to be the tune, and I started messing with the tune a lot. I had some people look at my tune and the results that it was getting, and were like, "This is really weird. It's acting more like a mechanical problem, or maybe you have a big vacuum leak because you just swapped the intake." So I pulled the intake off, replaced the gasket, did all that work again. That did not solve it at all, and then it just progressively got worse until the point to where you can't really drive it anymore, and that's when I kind of like said, okay, let's just restart all the diagnostics all over again, and pulled the second wire, and the end just basically disintegrated in my hand. It was all charred up. So it's probably had a poorly manufactured crimp inside that spark plug wire that created more resistance. And then, well, I'm going to guess what happened is it was fine for a while, and then when I did the intake swap and pulled the plug wires off, I probably made that connection worse to the point where it was probably arcing inside of that plug boot and then caused it to fail. So what I kind of want to bring up is just like problem solving techniques, right? Like when you start chasing your own tail, like I was for like the past 6 months on this problem, and then getting to the point, like when do you start to hit the reset button to start over? Or like do you if you have a team, do you like pass the problem on to someone else to have a fresh set of eyes to look at it? I don't know. Like I've never had this kind of problem before where like I couldn't figure it out kind of like in the first stab, right?
Cars are interesting because they have so many subsystems that are sequential, where you say, this is good, okay, move to the next step. This is good, move to the next step. And there's something really fun about that, where you can kind of conceptualize in your mind like how things are functioning, and you can work through it and say it can't be XYZ because I know these conditions are met. So move on to the next thing, right?
But that's what got me in trouble.
Yeah, exactly. In your situation, you had a latent failure that was not easily detectable. And those are kind of the really crappy ones. It's kind of like when, I'm sure you've experienced this before, where you have a PCB where it's working, then you hand it to somebody, and then it doesn't work, and they hand it back to you, and it works. And,
oh, yeah.
And it's something where, like, a slight board flex is the problem, and there's a trace that's making just enough connection. Those kinds of things will drive you absolutely insane.
And you end up being the person that's got like the magic touch that makes something work in the company.
Oh my! And you know what? I had an issue just the other day, where an operator came up to me and said, "Hey, I'm getting weird results from this one unit, and it's a product I designed." And he's like, when I turn it on, I'm only getting positive voltages from my sine waves that are coming out of it. So it looks like a rectified signal that comes out of it. I was like, okay. So I took it. I go and put it on my bench. Fires up great. No problems. So I hand it back to him like, this looks fine. Try it again. Maybe there was something strange about your setup. Doesn't work for him. So I take it. I go put it on a whole different scope, whole different power supply. Works. I hand it back to him. Still doesn't work for him. So I go into the testing room and I put it on 3 other test rigs, and it fires up fine for me. And I give it to him, fires up wrong again on his. So it actually ended up being an issue, a startup issue, where I had a capacitor that was right on the edge of tolerance, and just everything stacked up with his test bench and his sit rig and the way his power supplies came up when he turned on his stuff, and the tolerance of that one capacitor that is it's a ramp capacitor in a switch mode supply, that it would screw up on his. And I even tried getting a heat gun out, and I would just heat up that one capacitor and it would fire up fine on his bench, but when it cooled down it would mess up. And so it was just like a perfect storm of everything going wrong. And I ended up just replacing the capacitor, and it works fine. But yeah. Those kind of situations will just drive you nuts because because all you could do is say, like, it works for me. Right?
No, exactly. Like I was like these spark plugs and the plugs themselves and the whole ignition system was working fine before the intake swap, and they were only a couple months old at that point. So I'm like, that can't be the problem, because it was running fine beforehand.
Actually, okay, and that my mentality right there might be the issue. Is when you say that can't be the problem, that causes you to be blind to potential issues.
Yeah, exactly. Yeah. That's I think that's might be what it is just because something is new doesn't mean you didn't have an early failure or a manufacturing fault.
Right.
Yeah.
Okay, so in terms of problem solving techniques, one thing that I have learned, and I've learned it the hard way too many times, and I've started to do this, is just if I'm going to if I know something is wrong with something I'm trying to repair, and I get into it, and if it doesn't stand out to me quickly, and quickly depends on what it is. Quickly on electronics might be 15 minutes. Quickly on a car might be an hour. But if it doesn't appear to me quickly, I'll get out a notebook and I'll start writing down what I've done. And because I've learned too many times where I get 3, 4, 5 hours into trying to fix a thing, and then I forget what I've done.
And you start repeating.
You start repeating, and you have to go back. And that starts to become problematic with PCBs, because you can start getting into the problem of putting too much heat on parts, trying to reflow things or fix things or blah, blah, blah. And so there's sort of like 2 modes that you go in. Like the initial one is, can I fix this fast? And if that doesn't happen, you got to switch over to, okay, we need to put a lot of time into it. And that's the point at which I, like, if I reach that threshold where I know I'm going to need to put more time into it, that's when I start asking the question, at least at work, is this product worth my time? Is my boss going to be mad because I spent 8 hours of engineering time trying to fix a thing that cost $100, you know?
Yeah. Chris Kraft in our live chat says, if I run into problems, I usually don't assume anything is good and do a step-by-step test and measure the output at each stage until I find something that doesn't look right. Yes, that is what I should have done. I was looking at it as I had just made these radical changes to my engine. Those radical changes must have been the cause of it not running right.
Yeah.
And it ended up being the previous radical thing I just did had a latent failure that caused this to be. I thought it was a fueling issue or a air issue in the engine, or a mechanical issue eventually. Like I was thinking, like the valves were sticking or something like bad was happening to the engine, and ended up being nope, everything's all happy. But what I should have done is when I thought it was a mechanical issue, I should have just gone and measured the mechanical issues and seen if it was, because even though that was only the second wire I pulled and it was bad, I ended up doing a compression test on all the cylinders, and everything was like low, but everything was like really close to each other. So it's just a worn engine, but
they all drifted together.
Yeah, which is normal. That's how an engine has friction. So friction eats metal. So, you know.
Yeah.
it's for how old it is. It actually has more compression than I thought it would have. But that was my mistake. Is I should have investigated the system more fully and not assumed that certain subsystems were flawless because they were flawless beforehand.
Well, another pitfall, I'm sure we've all run into it, and we will continue to do it just because it's our nature.
Yeah.
If something stops working, having that mindset where you go, well, nothing's changed. Well, no, something has to have changed.
Yeah, something has to have changed. I agree there. Now, the trick is on that is I didn't change anything, so what did change?
Exactly. Like when you get called onto the manufacturing floor because something is not working and it was working yesterday, and there's like, oh, I haven't changed anything. Well, no, like let's not jump to that conclusion. Let's start looking at what has changed because obviously something has changed.
It's the code. The code changed.
Yep. That's it. Yeah, it's never hardware guys issues.
Never the hardware.
Nope.
Or
we're
the assembly.
Flawless. It's always those guys.
It's always the code.
Yep.
Oh man. Okay. So yeah, that's an interesting. Is taking a step back and don't assume that's the thing is if it's. You should probably look at what changed most recent because that's usually the cause. And if that isn't the cause or is glaring the cause, then what Chris Kraft said is correct, is you should just assume everything's broken and work through the system until you find what actually is the culprit.
And with Chris Kraft's example there, that works really well if you have a very linear system where A flows to B, flows to C, and you can start doing that. That you don't always get that lucky.
That's true.
But the thing is, I would say that a properly designed system tries to be linear. As much as you can, you try to do that, but you don't always get that lucky.
Yeah. Sometimes there's a lot of codependencies.
Yes.
So, because I think basically what made me start running around my tail on this one was I would look at the sensor inputs on my EFI system, and it would go super lean when it would pop. And so I'm like, oh, a lean backfire. So that's probably like a valve sticking open. What was actually what I think was happening was that cylinder was not running right. It like doesn't have spark in it. Fuel would pool up there and then ignite, and then excess fuel would go into the exhaust, and then the EFI system goes, hey, there's extra fuel, we should lean out the engine, and then that was causing my lean spikes basically because it would go lean and then cause the backfire, and so it was like this. Like, the sensors were telling the story, but I was not reading the story. I was reading it into a different language, basically.
You were reading what you wanted to.
I think so, yeah. I was reading what I wanted to. I wanted to blame the new fuel system so badly that I just completely was oblivious to the fact that it was just an ignition problem.
Yeah, makes sense.
So.
Well, also, if a cylinder doesn't fire, then your timing on how power is delivered gets off by a full cycle, and that's just going to make it run rough, right?
Yeah. Well, it always never ran really well to begin with because it's a really old engine. So it was like it would stumble sometimes with the old carburetor, but I was just chalked it up to it's an old engine. So it's back to its old ways, which is good.
When it comes to a worn engine, I'm not going to say worn out, but worn in, like what you have, just from my ignorance in automotive, can you run into issues with putting new equipment on a worn engine because they haven't drifted together?
Only on mating surfaces that move.
Okay. Yeah.
Sure.
Like seals are tough on things that haven't worn together.
No, not really. Like rubber, like if you replace a gasket or like a seal, like on a rotating assembly, usually that's fine. Like you don't really have to worry about that. what you have to worry about is like metal on metal contact surfaces, like bearings, or the main one is, especially in older American cars, which are push rod driven camshafts with where you have basically a lifter that is riding on a lobe of a camshaft with like a thin oil, and those wear together because how when the cam rotates, the lifter actually counter rotates on top of it to kind of like make a slight dish into the bottom of the lifter, so it like rotates correctly and lubes itself right. And if you just throw new lifters in there or a different camshaft or get them mixed or the lifters mixed up, which ones go where, that you will eat a camshaft just totally. Like it'll just eat it alive.
So do you replace them all at the same time? Is that the solution?
If you replace a lifter, some people have managed to get away with it, but most of the time it will just eat your cam alive. Usually when you replace the cam, you replace the lifters as well. Or you replace the lifters and then you also replace the cam.
Makes sense.
But that's only on like push rod engines. Like other engines have other probably things that are like that too. Similar. Basically, it's like if it's a metal on metal contact surface, then you have wearing in things to worry about. But yeah, you can put like a new intake or whatever on an engine, it's fine. Though you're putting like brand new parts on a greasy old engine. Is that always a good idea? Probably not, but whatever. We do it for fun.
Why not?
What is it? Too good of parts on cheap enough junk. So we've all been there. Okay, so before we're gonna wrap up soon. So I got some kind of announcements, kind of things. These don't really fit in the news segment at the very beginning, though. The power distribution module. Some people were asking about this in the Slack channel. So what is up with this project? I'm kind of waiting to finish up a side project for the podcast before I start this project, because I want this one to be kind of community driven, open source, and I want a place to discuss it correctly. And that correctly part has been a discussion between Steven and I, Misha, which is the CEO of Macrofab, marketing at Macrofab, and then a couple other people I've talked to that are also running communities for engineers and the like. And I think what we're going to do is build a Stack Exchange kind of form for the podcast, so that we have a place where people can discuss the podcast, talk about their projects, talk about our projects. And it's also a place where like the history doesn't just vaporize in 3 months like it does in our Slack channel. And
it's searchable.
And it's searchable by Google, so that if someone wants to search for something, let's say, because actually like the problem now is people will ask a question about Macrofab in our Slack channel and we'll answer it. But then in 3 months that answer goes away, or like someone just Googles that question and it doesn't pop up. So with the Slack channel is not going to go away, but I'm going to start building this Stack Exchange form kind of thing, and we're going to try it out. I already have the website. It's meffer.io. That's going to be our test bed for it. It doesn't go anywhere, Steven, so don't even try.
Aww.
It just goes nowhere right now.
Dang.
So, yeah. But I'm going to build that up, and then when that's built, the first project that I'm going to put on it is the power distribution module. And then what we're also going to do is do our first contest in forever. So we're going to...
It's been a while.
Yeah, so we're going to bring the contest back. I was talking with our marketing team, and they want to do a contest a quarter, which sounds like a lot, but we're going to try it. So,
cool.
Everyone out there in podcast land that's listening, let us know if you have any ideas for like contests that you want to see. Like the last one we ran, unfortunately, I think like Steve and I peaked at our idea, which was like the most useless thing.
Yeah, that was
It
fun.
was such a
That
great
was
project,
super fun.
like it's such a great topic for a contest. So if anyone else out there has ideas, Steve and I will brainstorm some ideas too. We're not out of ideas yet. That's impossible.
Yeah, 372. We're still going.
Yep. So, yeah. That was the Macrofab Engineering Podcast. We're your hosts, Parker Dillman.
And Stephen Craig.
Later, everyone.
Take it easy.
Thank you, yes, you, our listener, for downloading our podcast. If you have a cool idea, project, or topic, let Steve and I know. Tweet us at MacFab, at Longhorn Engineer, or at AnalogENG, or email us at podcast@macfab.com. Also, check out our Slack channel. You can find it at macfab.com/Slack. I got kind of worried when we still had like 2 topics left, and there was like 56 minutes in. I'm like, okay, time to rush this.
We're
We got
fine.
We got it. When I get paged at 3 a.m. through, though my first question is usually what changed. Because, Chris Kraft, usually what changed is usually what caused the problem. Usually. That's why I'm saying that's usually a good first attack. My problem is I let that guide my diagnostics for 6 months. Instead of after the first stab at it, I should have just done a full, what you just said, regression test. Is just start over. So what you're picking up?
I don't know where they're at. I need to find them. But first of all, I got that done at Send Cut Send,
Ooh.
which is pretty legit.
Is it powder coated too?
Oh yeah. That's I'll show when it's fully built. I'll show you this. But that's like a back panel so you can see into it. But it's also, these are just heat vents.
That's so cool.
This is a rear panel for something. Aluminum PCBs. They make really great panels for prototypes, and they're cheap.
Yeah, that looks great.
It looks fantastic. I'm super happy with how those came out. I mean, if you really look at the silk screening, there's like lines in it. I wouldn't use this ever for production, but for prototyping, they're dirt cheap.
It looks
and
better than
gives you.
It looks better than just a flat piece of stock or whatever with holes drilled in it.
For sure. Yeah, that has PCB panels on it.
Whew. Almost got all the data.
Rad.
Yeah, I'm hoping tomorrow when I go to work, I'm going to drive the wagon. I'm going to see if it backfires. If it doesn't backfire, that means I fixed it.
I mean, you found the smoking gun, so.
I think. Though
We got our. Oh, sorry. Go ahead.
Oh, yeah. I'll send you the picture. What it looked like when I pulled it out. Basically, like I pulled the spark plug wire off, and 2 pieces came out, which is not a good sign.
Yeah.
And when you look at like the terminal, it's like all crispy.
Yeah. Yeah, you were arcing like a madman.
Yeah.
So we got our car back and everything's great. Just drove off the lot.
The Kia.
Yeah, killed in action.
Well, now it's got another 60,000 miles that will go before it eats itself again.
105.
105. Oh, actually, you went above the normal average on engine then. So apparently, it's like the
The
bearings.
average is less than 105.
Well, they had badly manufactured. Basically, they used the wrong material for the bearings.
Yeah. Yeah, and I asked them. I was like, "What was the issue?" And yeah, bearing crapped itself.
Yeah, basically,
So-
like the bearings on those engines don't have the right hardness or the right material, and the bearings will eat themselves alive, and then it will shred so much material that it will clog the oil intake, and then the entire engine seizes at that point.
Yeah, it's a runaway feedback system.
Yeah.
Yeah.
But
So-
it's just bad bearing material is what ends up being. So I think the replacement engines have better materials for that, which is good.
Yeah. I sure as hell hope it does.
Yeah. Well, it's like the problem with a lot of GM engines right now are they have bad, poorly manufactured lifters in them, and so some engines will tick, and they'll just tick for like when they're brand new, and GM's just like, it's fine. It's like technically yes, but a brand new engine shouldn't tick. So.
Yep. Well, I dodged $5,000, so
Yeah, there
I'm
you go.
happy.
I once had an odd issue, and I kept taking it in, and they kept implying I was insane. Then they found a hairline cut that was most of the way through one of the plug wires. See, exactly. Ignition problems are really hard to diagnose because my engine would actually run. It would start fine and run fine until it got mostly up to temp, and then it would start to miss, and then the hotter it got, it would get worse. When this first started, though, it would just randomly backfire every so often. It wasn't like a big deal. Which, looking back on it, yeah, if it was an engine, and it would only do it on like the freeway, which would make sense though, is if it was running at 3,000 RPM on the freeway, and then one of the cylinders decided to be like, nope, I'm not gonna fire at all. Then yeah, that would cause a huge miss.
Yeah, and then puke all of that fuel into your
exhaust. Yeah.
Yeah. That makes sense. I mean,
Yeah. Look, in hindsight, yeah, it makes sense. I'm hoping tomorrow I'm not eating my words and like it drives into work perfect, no backfiring. So.
guess you'll find out.
Yeah. But I probably damaged that spark plug when I did the intake swap. That's probably what happened. I probably yanked on it at the wrong angle and damaged the crimp in there, and it worked fine until basically it starts getting warmer down here again, and it's like, okay, it's time to it's time to die. I'm gonna stop the stream, so